Hey guys, today we're going to be doing a significance test for the difference of two proportions. We're going to use some similar information that you might have seen before. The random sample we're talking about is 100 US adults where 60% of them prefer YouTube to live TV, while in a sample of 100 US teens, 80% of them prefer YouTube to live TV. We want to know, is there evidence of a difference? Now, the first thing we want to set up is our hypotheses. So H naught is going to be that P1 equals P2, and your alternative is going to be that P1 does not equal P2. We just want to know if there's a difference, not if one is bigger than the other, so we're just going to use the not equals sign. We probably should define our parameters here as well. So P1 is the true proportion of US adults who prefer YouTube to live TV. And P2 is the true proportion of US teens who prefer YouTube to live TV. So I'm going to put some quotes because we're basically saying the same thing, but we're saying it about the teens. So if you recall from before, we set P hat 1 equal to 0.6 and P hat 2 equal to 0.8. In order to check our conditions here, we're going to have to find our pooled p hat, which we're going to call p hat sub c, and that's found by doing x1 plus x2 over n1 plus n2. x1 and x2 are the number of successes in your sample. So if we have 100 US adults and 60% of them are preferring YouTube, that means that the success means however many in that sample are preferring YouTube. So our p hat sub c is going to be 60 for the adult group plus 80 from the teen group over 100 plus 100 because both groups had 100 people in them, and that would be 140 over 200, which is what we're going to use, 0.7. So we're going to use that in our calculations. We're also going to use it in our condition checks. So your conditions are the same, random independent samples, your large counts condition. The only thing that flips up a little bit is your large counts condition uses p hats of c instead of individual p hats. So if we were to do that, we would have 100 times 0.7 equals 70 is greater than or equal to 10, and 100 times 0.3, which would be 1 minus 0.7, is greater than or equal to 10. Because our groups are the same size, these are just going to actually both be the same. So they all check out. From there, we head on into our actual calculations. This is kind of a long one for a z-score, so we would have z equaling your statistic, which is p hat 1 minus p hat 2 minus the parameter, which is p1 minus p2. We're expecting this to be 0 here, no difference, divided by the standard error, which would be in this formula, this is where also p hat sub c comes into play. So then if I plot my numbers into that, I have z equals 0.6 minus 0.8 minus 0 all over the square root of 0.7 times 0.3 over 100 plus 0.7 times 0.3 over 100. So these are both 100 because we took the same amount in our samples, and we get a z-score of roughly negative 3.09. So if we were to look up this in our normal curve, that would be very far to the left, so negative 3.09. I'm going to draw here. This is a two-tailed test, so we also care about the positive. That's how the picture would look. If you want to go the quick route and just do 2 prop z test, we have z equals negative 3.09, and your p-value that you get is 0.002. Keep in mind the calculations for the calculator and the actual formula might be a little different, but they should be very close. And our last step is to conclude. So we reject H naught since 0.002 is less than our alpha that we generally set at 0.05. We have evidence that the proportion of adults and teens who prefer YouTube differs. Because our results were so extreme they wouldn't be happening by chance, we have evidence that these two proportions in these different populations in fact differ. There you have it, a two proportion Z test.